All right, let's get into this. I want you to picture a construction site. It's muddy, it's chaotic, it's loud. Now picture a software engineering lab. It's clean, quiet, totally digital. These two worlds could not feel further apart. But today, we're looking at a company that has basically fused them together, not just to haul away some trash, but to turn that trash into a data high-fidelity stream.
In this quote right here, it nails the entire story of 905 Wood. This is not about garbage bins and big trucks. It's about taking a raw material, in this case, piles of discarded wood, and refining it. But the secret, the real magic, isn't in some chemical plant. It's all in the software. They have literally built a digital refinery.
So, what problem is this digital refinery actually solving? Well, it's going after what the founder calls data anarchy. For decades, in the construction industry, waste management has just been a world of total chaos and, frankly, a huge liability.
And this comparison just lays out the whole shift perfectly. The old way was pure data anarchy. You had messy handwritten receipts, no real track record of where anything went, and that wood waste, it was a complete financial black hole. The 905 Wood way changes the game. It establishes what they call operational truth, with a perfect digital audit trail, turning that massive liability into a potential revenue-generating asset. The stakes really couldn't be higher.
The person who designed all this isn't your typical tech bro from Silicon Valley. The founder, Mike Atkinson, is a true hybrid. He's got 14 years of muddy boots experience driving trucks and hauling heavy loads, but he's also the architect behind the software. He gets it from both sides. He understands the real-world friction of a job site and the elegant digital solution needed to fix it.
Okay, so let's peel back the first layer of this refinery, the tech that meets the driver right where the waste is created. They call it the compliance gate, and it all happens on what they call the tactical edge.
So here's the absolute key. The intelligence, the brain, has to live on the device itself. They've built this system on a Pixel 10 Pro, running a super optimized AI model through a framework called Light-RT. What that does is strip out all the old clunky software bloat. This lets a driver, standing right there on the muddy job site, get a clear answer. Is this wood clean or treated in less than 2 seconds? No cloud connection needed.
Now, to pull this off, they use a technique called quantization. And I know, it sounds super technical, but the idea is actually pretty simple. It's basically a way to shrink-wrap a massive, powerful AI brain so it's small enough and fast enough to run on something you can hold in your hand.
The absolute best analogy for this is compressing a 4K movie. You take this gigantic file that would normally choke your phone, you squeeze it down, and yeah, you might lose a tiny, unnoticeable bit of data, but in return, that movie now plays instantly, anywhere you are. That is exactly what quantization does for their AI model.
But making this choice wasn't easy. It actually created a huge internal engineering debate. On one side, you have the skeptics saying, wait a minute, we're looking for things like arsenic. Reducing precision even a little bit sounds like negligence. But then the advocate comes back with the cold, hard reality of the job site. If a contractor has to wait even 10 seconds for a spinning wheel because the cell signal is bad, they just won't use the tool. Speed isn't a feature, it's a requirement for this to even work.
And this is exactly why their choice of hardware is so critical. The Pixel 10 Pro, with its Tensor G5 chip, isn't just a phone in this context. It's a serious industrial tool. That chip is so efficient it can run these heavy AI scans all day for an 8-hour shift without overheating and throttling, which is a massive problem for other devices. Its on-device power means it works perfectly in a concrete basement with 0 bars of service. And this idea of agentic compliance, it just means the phone is smart enough to know a critical safety alert is more important than a text from your friend, so it actively manages the driver's attention.
Okay, so the device at the edge makes a lightning-fast call, but how does the system make sure that call is accurate and auditable? Let's move up to the brain of the operation and see how it actually architects a single source of truth.
What's brilliant here is that the system is smart enough to know what it doesn't know. If that AI model sees a piece of wood it's not 100% sure about, maybe it's old, wet, and weathered, it doesn't just take a wild guess. It flags that image and immediately sends it to a human expert. That expert makes the final call, and here's the magic, that correction gets fed right back into the system. So the AI learns from its own uncertainty and gets smarter and smarter with every single scan.
But wait, it gets even smarter. The platform uses a powerful technique called retrieval augmented generation, or RAG. And this is a huge deal, because what it does is it forbids the AI from just making stuff up.
It forces every single decision to be based on, to be grounded in, a very specific knowledge base, the complete, unabridged text of Ontario's environmental regulations.
So, let's walk through what this looks like in the real world. Say a load of wood fails a secondary chemical screening because it has high levels of arsenic. The system doesn't just spit out a generic rejected message. No way. It automatically queries its legal database, it retrieves the exact section of Ontario Regulation 347 that defines the legal limit for arsenic, and then it generates a rejection notice that literally cites the law, saying something like, load rejected, arsenic levels exceed Schedule 4 leachate limits. This is explainable, it's auditable, and it's a legally rock-solid reason for compliance.
So we have this incredible technology stack. It's fast, it's smart, it's legally sound. But what does all of this mean for the bottom line? This is where all those bits and bytes get turned into actual dollars, transforming what used to be a costly headache into a valuable asset. The key to the whole financial model is a concept they call decoupled billing. Instead of just sending one flat fee for a dumpster, the invoice is broken down into separate, transparent line items. And this transparency is what lets 905 Wood create this really powerful financial incentive that actually changes their customers' behavior back on the job site.
And here's where you can really see the psychology at play. A customer looks at their bill in the app. They see the logistics cost, they see the weight cost, and then they see a third line, a potential $60 per ton regulatory levy. But the second their load is scanned and verified as clean, the app visually zeroes out that levy in real time. This isn't some rebate check you get 6 months later. It's instant financial gratification for doing the right thing.
So what's so powerful about this is that the system creates value in two directions at the exact same time. On one side, the customer avoids a penalty, basically getting a diversion pass that turns that $60 a ton fee into zero. And on the other side, that same clean wood is transformed from a disposal receipt into a carbon dioxide removal certificate, or CORC, which is a brand new revenue-generating asset. And we're not talking about abstract concepts here. For every single dry ton of wood that is properly diverted and sequestered, the system can verifiably track the removal of about 3/4 of a ton of CO2 equivalent from the atmosphere. That verified data is the raw material for a valuable carbon credit.
So when you put it all together, the hardware, the AI, the legal grounding, the financial incentives, the 905 Wood platform is so much more than an app. It's really a sentient bridge, using cutting-edge tech to connect the absolute chaos of a construction site to the incredibly high-purity demands of the new circular bioeconomy.
And that's the thought I really want to leave you with. If you can build a digital refinery for something as messy as wood waste, what other materials that we currently call waste are just sitting there, waiting for the right software to unlock their true value? What other high-fidelity data streams are we currently just throwing into a landfill?